Hello, my name is Jacob St.Martin, and I am happy to present the mid-project progress of BELLE. The system starts with the laser firing from the beam collimator. The 8mm beam then travels to a beam expander, where it is expanded to 24mm and given a uniform profile. Next, the beam is directed by a galvo, where the direction of the beam is controlled by a system of 2 mirrors. After leaving the galvo, the beam strikes the solar cell on the rover, where a small portion of the beam is reflected. This reflected beam travels back to the rest of the system, where it is collected by a quad detector. The quad detector measures the intensity of the incoming beam. Based on this measurement and our tracking algorithm, the microcontroller sends a signal to the galvo so that the system tracks the movement of the solar cell.
So here we're just demonstrating simple X motion, just a sine wave on the X. And we can do the same for the Y stepper motor. So we have independent axes of motion there. You can show by combining these we can draw circles or other more complicated shapes. I'm drawing just a faster and faster circle there to show sort of how fast we can scan. And now it's just entered the sort of radial tracking mode where it's drawing larger and larger circles. And it's checking the photosensor all the time, which is right here. This is the photosensor. And if I take the piece of retroreflective tape, which is this guy right here, and I place that in the path of the beam, you can see it'll lock on there, and it'll follow the beam.
In the next phase of our project, we will work to fine-tune our tracking algorithm, build a quad detector rather than a single photoresistor, and will be using a more advanced laser and galvo system. We are also in the progress of 3D printing mounting components to ensure the consistency of our experiments. Here you can see the galvo, which controls the motion of the laser. The galvo is composed of 2 mirrors, one to control the vertical motion, the other to control the horizontal motion. By moving these mirrors, the beam can quickly be scanned across a large area. Rather than build a rover from scratch, we chose to use a commercially available rover, which is seen here. This clip shows the rover being controlled with a smartphone via Bluetooth, but it can also be programmed to follow a specific path. We are incredibly grateful for the opportunity to develop BELLE, and feel that we have made excellent progress given the difficult circumstances at hand.